G'day, our next topic for extension maths is chapter 12. Now chapter 12 deals with lots of different things, but it starts off with sort of classifying numbers. We classify numbers in two different ways for this topic. One of them is rational numbers and the other one is irrational numbers. Now I've just grabbed this from the textbook that you've got, and you can read up on a little bit more if you'd like to know a bit more about it. But first of all, I want to explain what rational numbers are over here. So rational numbers can be integers, whole numbers, positive and negative, and they can also be terminating decimals. So things like 0.8, because there's nothing that exists after the 0.8, it just stops at 0.8. 1.23, as you can see there, or even this one here, 0.0006. Okay, so decimal places that there's zeros after that. There's zeros after the 6. There's zeros after the 3. There's zeros after the 8. Or recurring decimals, so terminating decimals, when there's nothing more, or recurring decimals. Like, for example, 1/3 can be written as 0.3333 recurring forever. I would much prefer you to keep it as a fraction than to try and write it as a decimal, but still, both of those things are true. Or this one, 7 divided by 11, 0.636363, that just recurs over and over again. So these things are all called rational numbers. Now, irrational numbers is probably what we're going to focus on a little bit more in chapter 12. Irrational numbers are, I guess, ones that don't have a repeating decimal or are not integers. We call them surds, and this is the word that we want to look at for probably the first half of this topic, actually, dealing with surds. Surds are, these numbers here are surds. Surds, the way I can describe it is basically a square root that doesn't work out nicely. So we know that the square root of 4, for instance, is 2, and the square root of, say, 16 is 4, but what is the square root of 7? Or the square root of 11 or something like that? It doesn't have a nice number, and in fact it doesn't have, if you did that on your calculator, it would repeat, so there would be no repetitions at all. The decimal places would keep going and going and going, kind of like pi. That's one of the other ones that we've got as well. So that's all I'd want to say about rational and irrational numbers. The only other thing I want to draw your attention to is just this little helpful thing that we'll look at it more later on, but I want to start you off on it. So I want to write down the numbers 1 to 10 down here, and then I will, above that, I'm going to write the squares of those numbers. So for example, I'm going to call these ones x, and the other ones above I'm going to call an x squared, and I'm going to put it in a different color just so that I can see that. Okay, so 1 squared is 1, 4, 9, 16, 25, 36, 49, 64, 81, how am I going? And 100. Okay, now the last thing I want to do is I just want to put a square root on the top of all of these numbers here. So the black, if you like, can be the square root of x. Okay. The reason I want to do this is because this will become really helpful later on, but for now, anytime you see the square root of 25, you can replace it with a 5. Square root of 81, you can replace it with a 9. I know that that's probably obvious, I know that you'll probably do that anyway, but this will become really useful later on, and I just want to kind of introduce it to you now, because later on it probably won't be as obvious as that, and I'll show you in just a little bit. But for now, that's pretty much all you need to know to go and do 12.1. So if you'd like to go and do 12.1, that's completely fine. If you want to keep going with some more theory, watch the next video that I've got, which is all about multiplying, simplifying and dividing surds. But feel free to now start 12.1 from here.